Hey guys, welcome. I thought I'd give you a bonus example on Trig Sub, and this is from an MIT recitation in single variable calculus. And of course, as usual, may the Lord Jesus Christ bless this video, bless you and I. And yeah, so when you see an integral that looks like this, the first thought should be, can I do partial fraction decomposition, right? Because, well, usually we do trig sub when the quadratic is trapped inside of a square root. When that's the case, which is when we have a quadratic trapped inside the square root, we can also do Euler sub. I have videos on that, so check that out. But we can do trig sub when we are unable to factor this quadratic into a product of two linears, because if we were able to do that, which is, right, this quadratic is a product of two linears, then partial fraction decomposition is probably the easy way out, right? As we know, trig sub is kind of like an involved process. But here, the title kind of gives it away, as I said, or as I might not have said. So, first step in trig sub here is to complete the square on this quadratic. That's fairly straightforward. So, okay, so we go, all right, this is dx over, and so I'd write x squared minus 8x. To complete the square, I need to write plus 16, right? But then this is plus 1, so I need to retain that, so I go minus 15. And now, since this is 1, all is well. Okay, and this here is x minus 4 quantity squared, and that's what we meant by completing the square, right? This here is the same as this little guy, right? Okay, so why don't we replace it with what I just said it is? So x minus 4 squared right there. The minus 15 so distant. There it is. Okay, cool. Now, what kind of trigonometric substitution is helpful at this stage? Well, when you've got like a quantity squared where obviously the quantity you're squaring involves some variable here, and then minus a number, right? The correct substitution is secant theta, and that's because, well, recall that tan squared theta plus 1 is equal to secant squared theta. And if we subtract 1 from both sides of that, we see that we get tan squared theta is equal to sec squared theta minus 1. That's why the secant theta substitution is helpful. But what about this 15? Because it ain't a 1 over here, it's a 15. Also, let me write a 15 at the end. Well, I could do 15 here and 15 here. That's helpful. But this is a quantity squared, and so I can't have a 15 chilling out of like the squared quantity. So what could I do about that? Well, I could write square root of 15 right here, and then I could write that, right? And now, good, right? Because this says 15 secant squared minus 15. Once you factor out the 15, then you get 15 times secant squared minus 1. The secant squared minus 1 part is tan squared, and so 15 tan squared. Clever. Okay, so with that in mind, clearly x minus 4 ought to be root 15 secant theta. That's the correct substitution here. So x minus 4 be root 15 sec theta. All right. Now what? Now this. And so then we should find a replacement for dx. That means we should take the derivative of this on both sides. That amounts to saying dx, the derivative of this, and obviously the derivative of minus 4 is nada. It's equal to root 15. The derivative of sec theta is sec theta tan theta, right? Cool. This is called how you do integration very casually, because it's fun, like ice cream. Okay. dx is root 15 sec theta tan theta over x minus 4 is root 15 sec theta. And so you saw, like, I'll do it, but you saw that the denominator is just going to turn into 15 tan theta, but I'll do it. 15 root 15 sec theta, that is x minus 4 squared minus 15. Maybe it's helpful to some of you. For some of you, it's kind of redundant. Okay, and what I'm saying is this denominator is like, well, square the root 15, you get 15, and then sec squared theta minus 15, obviously factor of 15. Some people be like, factorize what? I ain't never heard of that, but okay, and so that's 15 times tan squared. Okay, and so 15 tan squared, 15 tan squared theta, right? Oh, my bad. Right here, I forgot. J'oublie le de theta. D theta. Okay, so root 15 over 15, right? And then integral, right? So I'm saying we take care of that and put it outside. And then one of the tans be taking care of one of the tans down here. The tan up there be taking care of one of the tans down here. So the survivors in the numerator are sec theta and d theta, and in the denominator we have just tan theta, right? All right, working out nicely. Okay, so then we go. Okay, so this is equal to root 15 over 15, and recall that secant is 1 over cosine, so 1 over cosine theta, and then tan is sine over cosine, so divided by sine theta over cosine theta, and then d theta right there, right? Okay, well, dividing by sine theta over cosine theta is same as multiplying by its reciprocal, so I'm gonna write times cosine theta over sine theta over here. Ah, nice, cosine theta over sine theta. You see what's happening? Okay, so this is what's happening. Like that, right? So we've got root 15 over 15 integral 1 over sine theta d theta. Cleaning up nicely, boy. Okay, so 1 over sine theta is cosecant theta. So cosecant theta d theta. So now we need to know the integral of cosecant theta. This ain't the video where I do that, because like it'll make this video unnecessarily long. So I'll dedicate a different video on how to find the integral of cosecant theta, and I'll show you 2 different ways to do it. I realized that I don't have a video on that, but for now I'm just gonna tell you the answer, because like I've got stuff stored in my head. And so it's gonna be root 15 over 15, and it turns out that the integral of cosecant theta is equal to the negative of the natural log of the absolute value of cosecant theta plus cot theta, and then of course plus c. Now, you know, I intentionally wanted to like exclude the integral and write in a parenthesis, but obviously no need. I could write the minus sign right there and scoot this over and write a plus c right there, right? Okay, but not so fast. We ain't done, because like we started off with x's. So how did we end up all the way there? Not a problem. Pas de problème. So specifically, we know that from this, if I divide both sides by root 15, I realize that I haven't used the blue marker at all. So maybe this goes, and then I've got secant theta, right? Okay. All right, cool. So then what happened is that there is a triangle right here, and it's a right triangle, so we could do trig on it, and this be theta, and I need secant theta to be x minus 4 over root 15. That means since secant is the reciprocal of cosine, I want cosine theta, if that's easier for you, to be root 15 over x minus 4. For me, I could handle that, because I'd be like, oh yeah, so cosine is adjacent over hypotenuse, and so secant must be hypotenuse over adjacent. So I'd be like, this is x minus 4 and this is like root 15, right? Okay, cool. And if you do some Pythagorean theorem, and you say like this be like b, and this be like a, and this be like c, then a squared plus b squared, remember, is equal to c squared. So it turns out that a is going to be like, it's going to be like the square root of, it's going to be the square root of x minus 4 squared, and then minus root 15 squared. Okay, see, this is what happens when you like live in New York. There's like crackheads at the dawn of crack. Like, listen to that. Can you hear? Okay, anyway, I'm gonna keep on going with my integral. Okay, so remember, this is gonna say square root of x minus 4. I have no idea what they're fighting over, probably like crack. Okay, minus 15. I'm so bad. Lord Jesus, please forgive me. Okay, so x minus 4 squared is like x squared minus 8x plus 16 minus 15. Ah, look, this here reduces to x squared minus 8x plus 1. Ah, I see. So I already knew that. Like, I could have just written it down. I was doing it for you. Okay, so this is going to be square root of x squared minus 8x plus 1. Now, remember, if you are doing trig sub correctly, right, whatever was in the original integral, that needs to somehow be involved, right? Like, and that's this here. So it needs to somehow show up in your final answer, and it does. Ah, nice. And that was done correctly, right? C squared minus b squared is equal to a squared. And so then c squared minus b squared under the square root is going to be a. I got that. I hope you didn't doubt. Okay, so this is all to say that now in our final answer, we need to come here. And since I don't have space, I'll just have to erase a key and write it like up here. Our final answer is going to look like this: minus root 15 over 15, and then the natural log of what? The natural log of the absolute value of, what's cosecant theta? Theta is right here. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant has to be hypotenuse over opposite. So that's x minus 4 over root, I'll have to do that again, my bad, root x squared minus 8x plus 1. That's cosecant theta plus cot theta. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So that's plus root 15 over root 15 over this. But wait, that means it's a common denominator. So in the interest of time, I do that plus c. Voila.